Okay, just talk about we'll do broad introductions and then we'll talk about the class, the plan, how I plan to handle the logistics of the class, and then do an introduction on the overall plan for this course. Okay. So, I will introduce myself. So,
Yeah, myself, Dr. L01, Assistant Professor at N01. Since I'm working here from Google.
okay, so we'll go around introducing all those.
Good morning, everyone. My name is V. Chaitanya. I'm an assistant professor from IIT Nashik. And also the part of this scholar is
Good morning, everyone. My name is Mangal, the scholar from BVRD College from North.
IIT Nashik. My name is Steve Vinay. I'm from IIT Nashik.
Good morning, everyone. I'm Brian. Thank you.
Good morning, everyone. I'm Prashant from IIT Nashik. Good morning, everyone. Myself, Shiva Prakash from assistant professor from SRM University. My name is Abhay. Hello, everyone. I am research scholar at NIT Arunachal Pradesh. I am Praveen Kumar. I am a PG student at NIT Arunachal. I am a PG student in Google Engineering. Everyone, my name is Sayom C. I am interning in NIT. Hello everyone, my name is Vikas. I am a PG student in NIT. I am Rohit Sagar. I am PG student in NIT. Good morning everyone, my name is Bhargav and I am a PG student. Good morning everyone, I am Bisa Rajan from Research.
Good morning, sir. I'm Vivian and from Institute of Technology. Good morning, everyone. I'm Vidya Khan, research intern under program sir and from Sri Ram Baba. I'm intern here from the program sir and pursuing my degree.
Hello sir, good morning everyone. I am Arvind. Good morning, one and all students here. I am Vigraj Shea, assistant professor, ATM College of Engineering, Karnataka.
Okay, welcome everybody to the class. So, in my profile, I talked about I want to briefly discuss my research, what I do, and then I'll go into how it relates to this class. So, uh, what I primarily do is build choice or econometric models. So, we're trying to understand behavioral process. So, it could be a decision process of an individual, it could be a decision process of an agent, such as a household. So, for example, thinking about where to live, that is a decision made by a household. Okay? If there are multiple people in that household, all of them is going to be affected by where he goes to school or where the two people, if they are employed, they are going to work and so on. Whereas if you want to go to a movie or not, probably that could be an individual decision at that time. So the agent might change. You might have an individual, you might have a household, you might have larger entities. For example, if you're looking at any planning decisions that are made at a district or state level, the decisions are made by urban regions or agencies. For example, in Telangana, it will be Telangana State Road, Corporate Transport, State Transportation, so on. So all of these, so the agents might change, but when they're making choices, there is a behavioral process that goes into making that choice. We're trying to understand that as a function of different attributes. So we develop choice or econometric models to reflect that. We're trying to replicate how individuals or different agents make choices mathematically. Right? So we know, for example, when you're buying a car, lower price is better. Yes, we know that. But how does that trade off with space? Or I want a 7-seater versus a 5-seater versus a 4-seater. So what is the cost you're willing to pay to get that extra? There is a trade-off between all of it. Yes, everybody would love to have a bigger car if it's cheap. That is qualitatively known to everybody. What we're trying to do is what is the premium people place on how much extra are they willing to pay for an extra seat in the car. That is what we're trying to do in developing choice or econometric models. We are trying to quantify already known qualitative relationships. Right? So as engineers, we like to put a number on it. We want to know what is the impact of that on. So for example, if you're a car manufacturer, there are people who love having, I think one of the numbers reported is 0 to 100 in 6 seconds, 5 seconds, 8 seconds, whatever that number is. Okay, there are people who will put value on it, there are people who might not. But depending on the understanding that process and the ability to capture that segment, right? So if 20% of the people probably would want 0 to 100 in 6 seconds, let's say, they're willing to pay maybe 1 lakh extra for that. So if you can figure that out, then companies can use that to invest resources in different technology. Right? So do they want to bring more space in the car, or they want to make their engines faster in terms of acceleration, deceleration, and so on. So understanding that comes from these models. So my research is focused on what I would call explainable data analytics. So it's not purely prediction based. Okay? So if you want to look at different data sets, if you have enough data, you can predict using AI methods or machine learning methods, where the accuracy can be as high as 95%, 98%. So for example, a simple example would be all of you either use Android phones or Apple phones or whatever. If you're using Google Maps or any of these applications, or if it is recording your location, it has trajectories of your last, how old your phone is. So let's say you have a phone for a year, it is recording where you've been every day at any point in time and space. So it has that information. So usually afternoon at 12 o'clock, where will you be? You can predict. Google will be able to predict that, given you give that access to the data, they can predict where will you be, maybe in class or at lunch or that. Now, choice models might not be able to compete with that level of accuracy when you're predicting it with that information. Right? Because in choice models, we don't use them. We can use long data set, but the prediction abilities are around 70 to 80%. But now you move. Let's say you are in Warangal, you finish your degree, you got a job, you go to a new city. Then Android or Google Maps data is new. So it cannot do a good job predicting because it's trying to match your performance in the last 6 months or 1 year. So it does well when the context remains the same. When the context changes, until you build enough data, these machine learning models or any of these models don't do a good job in predicting behavior. But our emphasis here is understanding why you are going. So we're looking at this class from 6:30 to 8 o'clock, or 9:30 to 11 o'clock. So if we recognize that, we can predict based on your work and travel constraints. So you have employment. So if I know that you are employed at a particular location, a choice model can recognize that behavior and incorporate that and build a better model even when a context switches. So the accuracy, when there is infinite amount of data, choice models might not have good accuracy. But when context changes, when you don't have enough data, even if you have only a little bit of data, machine learning models might not do a good job in predicting your behavior, but choice models do a better job representing even beyond the context for which you trained. Okay? And another important reason is, especially in transportation planning, is you don't know the future. Future changes. So if you have a machine learning model that is so well trained, it's giving you 99.9% accuracy on the current data, use that to predict, it necessarily does not reflect a good prediction because again, a lot of things change. Machine learning models might not be able to adapt to that change as efficiently. So what we want to focus on in my research group is focus on developing behavioral models which understand why people are doing what they're doing based on their age, gender, employment location, and then these relationships that we capture are transferable into the future or different contexts in a better. For example, in a machine learning model, you have a million records, you end up having 50,000 parameters. You can end up having a very large, especially the newer AI models, you can have a huge number of parameters. So what these parameters do is they give you a very high accuracy for the current scenarios. Okay, but these parameters reduce the degrees of freedom that exist for choices to happen. So when you take it to the future, they don't necessarily represent future data. Okay, so they will give you solutions that might not be plausible or feasible. So in our models, we are talking about a much smaller number of parameters. So if you have 1,000 records of data, usually the order of parameters in 10 to 20. We're talking about that few parameters. Okay, so that's where the microeconomic theory-based models can be helpful, and we focus on. And what we do after we build these models is we incorporate these models into large frameworks. So, for example, if you want to understand how transportation patterns evolve in urban regions, you need to understand where the population is going to go or grow in the future. What are the travel needs? What is the transportation infrastructure going to be in the future? How will this translate to vehicles? So when we want to model how many vehicles are traveling in front of an area road, for example, we don't just want to count data. Yes, we do that. Most of the projects are like that. You look at volumes of data, but people are not driving there for the sake of driving. Right? People have an origin and destination in mind and a purpose in mind. That's why they travel. If you understand that at an urban region level, you can predict individual trips on different locations much better. That's why we build travel demand models or regional transportation models that reflect the interactions of different people from traveling from their origins to destinations. These models have significant applications in understanding transportation planning demands for the future, but also you can look at emission models, you can look at health impacts of these transportation air pollution and so on. So they are widely applied. And even during COVID, there were health professionals who wanted to understand transportation models because we do very detailed mobility models. Because COVID transfers to as people move. So if you understand people's movements, you could track movement of the virus much better. So again, that's an area that is now, some people in the health field are starting to do what we do and think they're doing a lot, but then we have to show them that we've been doing this for 40 years in travel demand models where we predict people in continuous time and space. And you can track people, simulated people, not really people who are not doing that, at least not us. So we're trying to look at those trends as a way to understand different patterns. So once we are able to synthesize or simulate these behaviors, you can use this to understand how accessibility exists in an urban region, how firms are working, how different communities are handling current transportation. Now, if you look at global climate change and so on, we have issues that will create problems for transportation systems in this. You can have cyclones that will disrupt transportation systems. How do we build infrastructure that is resilient, and when a cyclone happens, how do you bring the community, recover the community faster? All of these also can use inputs from our transportation demand model. So we can, because we know where people are, what the mobility needs are, we can use that to create solutions for how do we evacuate these people if we need to evacuate them, and then how do we bring in resources for these people who are stuck in these locations at that time. So these the content framework that we worked on have been applied in different transportation areas. So the main themes that I work on in my group start with travel demand modeling. Again, as I talked about it, the emphasis is on building high resolution travel demand model. So we focus on synthesizing every individual in an urban region. So if you look at grid-based models, they look at zonal structure and develop models at zone resolution. But if you want to understand how people respond to policies and changes in the economy and so on, it's important to develop models at the lowest resolution possible, at the highest fidelity possible. So individuals are the one agents making choices. And if you go to the level of individuals, you can actually capture interactions among the household members. Right? So your household with two adults and no children, their behavior is very different than a household with two adults and children, because there is a potentially taking them to school. Maybe there's a bus that comes to pick them up, or parents are dropping them. So this will influence how they behave. So understanding that at a very high resolution will provide you better estimates of travel demand. So we've used this to understand demand, mobility demand, what is the demand on infrastructure, and now with the emergence of electric vehicles, a lot of travel demand models can be used to understand energy demand. Okay, because if we know how many miles they're going to travel, and if we know their car is an electric vehicle, we can identify what is that, how much charging they'll have. Maybe they'll charge it at home, or they'll charge it at a workplace or any other location. But just like we can estimate demand for fuel, we can also estimate demand for EVs. Now this is important information, because if you think about the traditional adoption of electricity use, the night time is when electricity use drops a lot, traditionally, because you switch off all the lights. Again, with the summer, probably ACs are going on, but in general, night times are when electricity demand is low. But if you think about bringing in EVs, that's when they start touching their car. Right? You come back home maybe at 8 o'clock or 9 o'clock and you start plugging it in. So the demand profile might change with a lot of adoption of EVs. When people are charging, might change, and that can create problems with the existing infrastructure. If you have the power grid system that is designed expecting a particular load structure, now that changes significantly because of transportation patterns. Like, again, right now the adoptions of EVs are not at a level where the grids are challenged yet, but if we want 100% EV adoption, like some of the government policies are suggesting increasing EV adoption, and there are resources to do that. So, but when that happens, we also proactively have to change our grid. Now, this is typically not an area that transportation people worked in the past, but because we know mobility very well, we know the demand of energy from mobility. So this is something one of my PhD students worked on to determine the demand. I also work on transportation safety, where we are looking at developing different new models to accurately understand the reasons for a crash. So there are two elements of transportation safety problem: crash occurrence and crash severity. So predicting how many crashes will occur and what is the consequence of that crash. Okay, we want to minimize occurrence, we want to make it zero. Vision zero is towards that. But given a crash happens, how do we reduce the consequence of the crash is also important, because we're not at a point where crashes are going to zero yet. So those are some of the things that I work on. Another aspect that I work on is emerging mobility, where we're trying to understand the newer modes. Right? You have the shared mobility system. I haven't seen bike share in India, but and scooters share in India, but these are coming up there. But we see a lot of ride-hailing services. Bike taxi, car, TNC, Uber, Ola, all of these are now widely available. So these are what I would call the transformative changes in the last 10, 15 years, right? With the adoption, access to technology in terms of smartphones and so on. Anybody can hail a ride at a very short notice. This was not possible until even 15 years ago. So now with that, people can figure out how to use these modes as last mile connectors. So I might be traveling from Vijayawada to Warangal on a bus, but then get down and book a taxi or a ride-hailing service to get to my final destination. So with good integration of emerging mobility services with traditional public transportation services, we can solve the last mile problem much better and encourage more adoption of the sustainable. So this is something we'll talk about as we go in the class also. Again, then there's also public transportation. So some of the work I do is looking specifically at public transportation systems and figuring out, okay, what are the current ridership numbers at different facilities? How do we, what is driving these numbers? So we can replicate this in locations where there is not that much demand. So some of that work we'll talk about it. And also how we can bring complementarity. So for example, if there is bike taxi and all of these that are available, how can we create synergy between public transit and that? Rather than trying to make sure that they compete, we can actually build a synergy so that we actually improve both systems efficiently so that we can increase sustainability. Then resilience is another area of transportation that is growing rapidly. I work in Florida. We have water on both sides. We are a peninsula, and the stretch of the state is only about 20 miles from sea to sea. So we get hurricanes from both directions. We have a lot of hurricanes, May to November, and evacuation is a challenge. Transportation evacuation is a challenge because we have only two highways running through the north-south of the region. So once evacuation orders are given, all roads are blocked all the time. So a 2-hour trip will take you 12 hours, 15 hours, and there are a lot of crashes because everybody is in a hurry to leave. So again, it creates a whole slew of problems. So we've been working on some of these aspects, and also we are looking at how communities respond to disasters. So again, the news focuses only probably a week or two at the time of disaster. After that, again, it's forgotten. But what we want to do is look at how economic activity recovers. Right? So the community is affected. Maybe it's a tourist location. Tourists are not coming back. When you do this coming back, what needs to be done to get them back into this location? Because some of the communities again in Florida is a huge tourist destination with Disney and all the beaches. So it's very important for local agencies to ensure that the tourism comes back as quickly as possible, because otherwise the people who depend on that, I think 15% of Florida residents depend on tourism for their employment. So 50% of the jobs in Florida are in the 10 to 15% are in the tourism industry. So you don't want all of them not to have their wages and so on. So it's a very important aspect. And another thing that happens in Florida is we don't have in the US. A lot of states have what's called state tax. So on top of income tax, state tax is levied to generate income. So for the state, it doesn't have a state tax. So the only way it generates revenue is what's called property tax. So they have taxes on your homes. So the state has an incentive to make sure homes don't get destroyed. Right? Because if homes get destroyed or a flood happens or a hurricane threatens a community, all the property values they go down. That automatically means the amount of revenue generated for the state goes down. So so it is in the interest of the state to implement solutions that prevent damage. So build levees, build solutions where the land around these house regions don't get eroded, so that again they don't go into the sea. They can sea level rise is a problem in Florida. How do you ensure? So we don't want to. Again, we are in a Republican state. I don't know if you guys follow the politics in the US. So the Republicans don't believe in climate change, or rather, they don't openly admit to it. So we don't want to go and tell them, no, climate change is real. You have to invest money in making facilities resilient and all. So we don't try that way. What we're trying to tell them is there is economic value in preparing for these disasters. Right? So if you ensure that the flooding does not happen, a community that does not flood, its property values will rise, which means the tax revenue generated from the community for the state will rise. So we want to look at it positively as you're proactively creating infrastructure that will preserve the value of the revenues in your state. So we are looking at data where we look at communities that are flooded in different hurricanes and see how long it takes for those communities' property values to recover back to where they were. So we can actually put a tag on the disaster, not only in the short term, but also in the long term. So if the property values go down, you are not going to recover for the next 15 years. It's going to, so the revenues for the county that is affected go down for the next 15 years. So a house that was 300 would probably be paying 5,000 as property tax every year. And if the 300,000 house becomes only 150,000, the property values have half. And so the revenue that you generate has half. So that is a major problem. So there's no other way to generate revenue in the state. So we're hoping this will be a more palatable way for them to think about these challenges. So we will see how it goes. Again, I also work a lot with interdisciplinary teams on understanding climate change and sustainability. And like I mentioned, I work with environmental researchers and public health researchers to providing them estimates of air pollution under different scenarios of EV adoption into the future, and also where the pollution is happening so that they can use this rich data in climate change models to understand how climate change will be affected with transportation. Transportation is only one component of the different facets of climate change research. Again, I only focus on the transportation side of it. So, with that, specifically in this course, what I want to do is I'll start with an introduction of the different opportunities and challenges for the transportation. Then we will provide exposure to some quantitative approaches so that we can understand data and build quantitative solutions to address these various challenges. Again, I want this course to be interactive. You feel free to stop me at any point. I don't want to be talking all the time. I would encourage interaction. So I have a set of slides I prepared, but my objective is not to complete all the slides. That's not what I want to do. Again, like my advisor used to say, it's not important to cover material, it's important to uncover material. So if you understand what I cover well, you will be able to read or learn the advanced concepts from it. If all I'm doing is covering hundreds of slides, it doesn't serve any purpose. So what is important for me is whatever you don't understand, please feel free to raise your hand, and I'll do my best to make sure I explain that well so you understand. Okay? What I'll do is all the course material will be online. So again, I can that way you can download everything from there easily. That's the link. I also put it small link. If you're typing that, you can see this. I'll use a website called Mentimeter to get some feedback, some background information, and so on. But it will be minimal. So I only uploaded modules 1 and 2 online. Depending on today, I will keep uploading every day new material on the website, and you will have access in real time. Any questions? So, you should be able to. go ahead and log in. I want to understand what your backgrounds are in statistics so that I can tailor discussions. I go to the next slide. Or be able to see the, if you log in, you can see the question right there. You will see the question. That's it. I mean, if you're a beginner, that's fine. Beginner is okay. I wanted to know some of you have looked at any urban regions or any specific systems in public transport. If you have experience with that, you can mention. those who are using databases, you get free license in India with universities or by purchasing it. Your researcher, professors are buying. Okay.
This purchase on behalf of the university for the laboratory.
Okay. The labs have sure. Yeah, I use SPSS for data preparation, descriptive analysis. I like it. It works well for large databases. If you have it, works well. I know, but yeah, of course, using R for everything now, so or R or Python for everything. Good. Let's see. Okay. If you are using RStudio, so we will do our tutorials in RStudio. You can install it easily, and give data sets and codes that you can run, and we'll work on it in tutorials. So that way, you'll get experience to exposure to some of those. Yeah, even for the graduate students, having experience with R is a good asset to have as you go forward.